Assalamu alaikum. Okay, we have another question on continuous motion and dynamics. What we have here, we have the acceleration of a particle along a straight line is given by this function. So a equal 1 over 4 s power half meter per second square, and s here is in meters. The velocity is 0 and the position is 1 meter when time equals 0. So when we started, we have these initial conditions. Determine the velocity of a particle when the position is 2 meter. Okay, now I have been given this function a equal 1 over 4 s power half. Okay, and I need to relate a with this. One of the differential formulas is that a equals v dv over ds. Okay, and here just a quick reminder, how do we have this? A is equal dv over dt. Right, now I can express a in terms of s and v alone without the time using the chain rule. So this is equal to dv over ds, right? ds over dt. So I can cancel the ds anytime and go back to this main definition. Now ds over dt is just the velocity, right? So now a simply equal to the v dv over ds. Okay, so it's just a quick reminder. How do you have this? Okay, now let me replace a here by the given function. So I have 1 over 4 s 1 over 2 is equal v dv over ds. And let me now just separate the variables. So I'll have 1 over 4 s power half ds equal v dv. Now once we have this, for every variable on one side, I can now do the integration. So now integrating both sides, we have 1 over 4 is a constant. I'll take it outside. Integration of s power half ds equals integration of v dv. Now for the limits of both integrals, we need to look at the conditions. When the velocity, when the time is 0 at the beginning, I have the velocity 0. So here starting from 0, and at that moment, s was 1. So I'm doing s from 1 and v from 0. Now since I'm expecting v to be a numerical value, right? So I just want to put v. What is that number? So it's just from 0 to v, any other v. And here on this side for s, I can immediately put 2. Why 2? Because we are evaluating, or we are trying to find the velocity at 2 meter, at the position of 2 meter. Okay, now let us do this integration. It's a simple one. I have 1 over 4 s power half, adding 1 to the power, I will have s 3 over 2, right, over 3 over 2. Okay, and the limit here is from 1 to 2. And for the right side, it's just half v square. Okay, right now, let us just simplify these numbers. This 2 will come up. So I'll have 2 over 4, which is 1 over 2. And I have 3 here. So 2 times 3 is 6. So I have 1 over 6. It's right. Power 3 over 2. 1, 2. Okay, I'm just doing that step by step. 1 over 2 v square. Okay, now I can cancel this 2. So this will become 3. And now at the same the same step, I will just substitute the limits. So I have 1 over 3 times 2 power 3 over 2, substituting the upper limit, minus 1 power 3 over 2. Of course, this is 1, but again, I'll just write that to remind you what we are doing. So this is equal to v squared. So now v will be the square root of this, right? So that will be v. Okay, so putting this into the calculator, I got the velocity at this position to meter to be, I got 0.781 to three significant figures, meter per second. Okay, I hope you find these videos useful. If so, please do share the videos and subscribe to the channel so that you can receive all the notifications. And please also support us by liking the video. Thank you and wishing you good luck.